Sorry. You still working at Castle this semester? Yeah. I'm going to do it actually. Oh, me either.
Oh, our noisy crew this morning. It's that Monday morning thing. Hey, we made it to week 2. That's better than some other universities, right? Yeah. All right, we're going to do this. At least till the end of September, right? What's the latest prediction?
End of September.
End of September, is that kind of what, that's where most of the faculty are. It's like, yeah, that's kind of what we're thinking. I never know. Our numbers are really low, so. Let me hit this. We're missing quite a few this morning. So let me hit this list real quick, just kind of keep track of who's here, who's not, and why. So, although I don't necessarily know the why. Cynthia Arnold. Nick Bradford. Nicholas Bradford. Okay. Trey Embry, Trey's back there. Katie Emmett, right there. Landon, BC.
It's okay. I've got that enough.
You've gotten that? Okay. That was not, please, that was not my intention. Sorry about that. No. Yeah. Move on. You never dig out of that hole, right? Spencer, Given, Spencer, okay. Ashley Johnson, Ashley right there. Kevin Mills, Kevin, good. Carson, there. Abby, back there. Drew is not here. Courtney, Travis Courtney back there. Ben, Roman, right there. Okay. Jared Wolf. No Jared. And Ryan right there. Okay, so. Okay. 4 missing this morning. So it's probably going to be the norm for this COVID season, whatever. All right, so everybody able to find the videos okay? Watch them, so they all right? It's a boring kind of a dumb way to learn, but hopefully it's better than, at least it's better than somebody sitting and talking over a PowerPoint, so kind of got a little bit of interest there. Hopefully that's okay. Was there any specific, well, this is what I want to do today, 4 things that I want to accomplish before get us set up for the lab on Wednesday. We're going to do the lab on Wednesday. So look at the procedures, talk about lab reports, how we're going to do those, where to find the OECD test reports. So I'll show you that real quick. And then Governor Droop was something that wasn't on the videos, so we'll talk about that as well. But do you have any questions about those videos before we start into this? Questions on Stuff in there made sense, pretty much, so it's okay. Maybe if we talk about it a little bit more when we see it in the lab, we'll be okay. Keep moving on, all right? So, all right, good. So keep me apprised, and that's what we'll do. That's one of the main things that we'll do in this discussion time. So when we come in here together, we will spend time to talk about those videos and any questions you have. So be thinking about stuff, and if you have specific questions or things, this is the time to be able to do that. So make sure you guys bring those in and ask those questions, and we'll deal with that and try to answer any of those questions that we possibly can. Okay? So make sure you're doing that in this time and so forth. Just let you guys all know that we will be recording this, as probably most of your classes are, so recording it for those that are not able to come for valid university reasons. So we're going to be doing that. Okay? Good deal. All right. Let's talk about lab. The handouts are over here. They are, you know what? I bet I forgot to put the lab handout online. I just thought about that. So it is probably not up there right now, but it will be as soon as I get back to my office after class. So I apologize for that. I think I forgot to do it. But so take a look at the lab handout, and it's the memo. So things a little bit different in here. So this is kind of the grow up and become an engineer time. So at least that's the way I approach these lab exercises. So what you're not going to get from me is step-by-step procedures. Here's what you do, step A, step B, step C. So this is kind of something like you would get in a real company that you're working for, all right? You're going to get a memo. They're going to send something to you. They're going to say, all right, y'all go, I need this test, go do it, give me the data, and send the data back, or send whatever back, answer whatever questions that you need to answer, okay? So that's what the handouts are going to be, what the labs are going to be. So you got to read that, and you've got to put a little bit of thought into that in terms of what data do I need to collect, and how much data do we need, and make sure that you get the right data to be able to answer the questions that are on there. So look carefully at the questions. So this first one this week is a pretty simple lab, and that's partly by design, just because to get us used to working in the lab, the procedures that we have to go through and stuff down there, the safety things and all that. So that'll give us time to do that, and to get used to the lab report format, which I do a little bit different. And I do it on purpose to kind of give us an exercise in a little different kind of writing. And so that's the way I approach that. Does that make sense? You okay with that? So that's what it is. So you're going to get these. You need to read those before you come to lab. You need to understand them before you come to lab. And it might be prudent, if you don't have a handout, I wanted to make sure that we all had one in our hands to look at together here today. But if you don't have that in your hands, make sure that you print it out, or at least you can find it on a device or something like that and be able to read it. So that is going to be critical. It's going to guide you. I won't necessarily hand them to you all the time. Okay? So make sure that you've got that and have that available as you come to the lab. Okay? So it is a memo format. Just a little bit more about how we're going to do things. The back of that handout are the lab groups as I broke them up. And this is based on that survey, who's available at 8, who's available at 11, who didn't have class at 12 or something. So I tried to lay this out as good, close as possible to, and some of you requested certain people that you like or whatever that you want to work with. Nobody told me people they didn't want to work with, so I guess we're all nice people in the lab. So, and I have had in the past, I've had people say, I do not want to work with so-and-so, and so that's what we'll do. There's some handouts there if you want to grab them. So, what's your name, sir?
Nick.
Nick, okay, good deal. All right, so these are the lab groups. So 8 o'clock, first group comes at 8 o'clock, and you're done by 9:15, or maybe even a little bit quicker this week. We'll see how it goes. If things go pretty smoothly, we should be out of there even quicker than that. So that's all you'll have to do on Thursday, so it'll be a fairly short day. So the second group then comes in at 9:15, and then the third group comes in at 10:30. Okay? So, and I'm not, you guys can trade if you would like to. So if you see somebody else or, you find somebody in a different group, hey, would you trade and I want to come, I'm open to that. So this doesn't have to be set in stone for the rest of the semester. I do want to maintain that balance in there. So if you need to move to another group, try to find somebody in that other group that can swap with you or something like that. So I'm open to that. So you don't have to do that necessarily, but this will give us a good start. What this allows us is smaller groups of people to be able to do these activities, get your hands on it, everybody gets to participate, and we learn a little bit better, rather than it's all standing around watching 3 people do the work, right? So that's not going to work out pretty well. So that's what we'll do on Wednesday. So again, Group A comes at 8 o'clock, Group B does not have to come till 9:15, Group C at 10:30. You got there. Questions about that? Make sense?
On Wednesday?
I'm sorry?
It's on Wednesday.
It is on Wednesday, yes, it's on Wednesday. Did I say Thursday again? No. I'm still stuck on that. So my other class lab is on Thursday afternoon. So no, I'm sorry. Yeah, it is Wednesday. So we'll be doing this Wednesday morning. So golly, the date is on the 26th. So yeah, today's the 24th. So the date of the memo. I try to put the test date. So the date of the memo is the date that we're going to be doing it. I try to do that. I don't know what's cat's at. So, but that is the date that we're doing it. Okay. So that's the memo. Attire for Wednesday, these dynamometers are very hot. You saw that in the video, that whole thing is a big tank of water, and we have to run the water through it because it'll melt down. I mean, it gets just a lot of energy that's just getting dissipated into heat. So we've got hot water flowing around. So I'm going to ask that you all wear long pants, closed-toed shoes for Wednesday. So make sure that you have that just for safety reasons. Some of the other labs we won't be quite so strict on it, but make sure for Wednesday that you've got closed-toed shoes and long pants. So that's something that you want to get in the habit of before you come to a lab. Say, oh yeah, we're having a lab on Wednesday. Just run through your head, make that a habit. Okay, what do I need to wear? So think about that attire so that we have proper attire and we don't have to, then you can all participate. Okay. So that's where we'll go from there. Let's talk quickly about the lab report format, because these labs are a memo, so I want a response to that memo. So that's what I'm looking for. So you've got a fairly lengthy, detailed description of that, and I'm not going to sit here and read it to you. Let me give you the philosophy of that. You guys read it, and then by Wednesday, if you have questions, we can talk about it. I'll try to answer questions. But basically what I'm looking at is a response to this memo. So whatever I have sent to you, you're going to respond to that and say, okay, here it is. Here's the response. It's going to be interesting and a little bit easier writing in some ways because it's a response to a memo and it's a personal communication response to that memo. You can use first person, which is kind of like, oh my goodness, nobody ever lets me use first person in engineering. So we can use that because that's a reasonable way to communicate. Okay, and I'm doing this on purpose because this is the kind of communication that you will do in companies. This is kind of common. And so we need to learn to be able to communicate in this way and be able to write like this. So it's a little different style of writing. And we'll get used to it. We'll learn it as we go through the semester. So first person is okay on it. And what I want is, so pretend I'm a boss who's very, very busy, and I've got a bunch of people who I've asked to do things, and I want a very, very quick response to this thing. So the back of that lab report, I made up a stupid thing about, I don't know, what was it, Bugaluna melons or something like that. Made up kind of a stupid lab report. But this is kind of an example of the response that I want. And so one of the challenges that you guys are going to have is you've got one page to tell me the summary of what you did. So one page to say, okay, remind me first of all, in the memo, hey, you asked us back in, don't say hey, but that's the kind of idea. So, you asked us on whatever date to do this particular test or perform this function or whatever it was. And this is our response. So right away I can read that memo and say, oh, okay, yep, that's right. I do remember asking them to do this. What did they find? And then you're going to tell me the key results right next to that. Okay, so what were the key things that I was looking for in that initial memo? So in this week, hey, test the tractor. Tell me if it's up to snuff, if it meets the, if it's operating close to the the original specifications and what the test report says it should be operating at. So it's a fairly straightforward kind of thing. So you're just going to tell me, hey, this is what we found, this is how much power we got out of it. The OECD report says it should have this much. Yeah, it's pretty close. Nope, it's no good. Something's going on, whatever. So, you know, very quick kind of responses like that. So you want to make sure that whatever question is in that memo is answered briefly and succinctly on your response. Okay? So you've got a minute. Okay? So think about that. You've got a minute. So I should be able to pick up your lab report, and in a minute I should be able to look at it and say, all right, yep, that's what I asked them to do. This is what they told me. Good. So, and a lot of times I'm happy with that. So, hey, this is what we found. That's the results. Lay it on the pile, put it in the file, do whatever with it, I move on. So in a corporate setting, that's what I might be doing. Now, I'm not going to do that because I'm a teacher and I've got to look a little bit deeper than that to make sure you're not just blowing smoke. And so there's supporting information that goes behind that, okay? So you can almost think of it as appendices or something like that that are attached to this thing, okay? And so the first one, and what I'm suggesting, so this is what I'm requiring, what I'm specifically asking for, is I want this one-page summary that tells me, executive summary tells me everything that you did. You may have another page, a second page, for key graphical information. Now this week, it's a pretty simple graph. You may actually be able to incorporate the graph in the memo, because if there's not a lot going on, you can put that graph there and show it to me, and you've got room to do it, so you can put it in that memo. But if it gets cluttered, if it gets squeezed or whatever, you can have a second page behind that for the key graphical information. So oftentimes I'll ask you for, in this particular case, we're looking at the engine performance curve. Show me the engine performance curves on the second page. Okay? So, one-page summary, second page right behind it for the key graphical information. Then everything else that I need to have with this report is going to be behind that in what we call supporting information. And you've got like a table of contents, and you want to put that table of contents on the front page of your summary. So, and this is going to vary from week to week depending on what you're going to do. So you're going to have, may have a section on further discussion of test results. So you may have found something really wonky and you didn't want to go into that detail on the executive summary up front. So in the supporting information, then you break it down and say, okay, here's what we found. We did this. On this particular situation, the machine did this, and so we think this is why it is, so there's a little bit more discussion that's going on there. Okay, so that goes back in there. So you might have a section for further discussion if you need it. Sometimes you don't always need it. You're going to have a section on test procedures. So I want a little bit more detail. I don't want all the detail of what kind of procedures you did up here, but I want a little bit more detail back in there and say, okay, this is how we tested it. This is the dynamometer we used. This is the procedure, whatever. This is some of the environmental conditions that might be key to this the test or whatever. So some of those test procedures will be back in there. If you have the extensive calculations, you want to have a sample calculation page. So, I don't necessarily, if it's pretty simple stuff, really basic stuff, we may not need to do it. But if there's a little bit more calculations, things you need to do, then I want to lay that out in here. Okay, so you might have a sample calculation section. Justification of time spent on the project, we won't need to do that necessarily. But you're going to want to include your original memo back in there, so a copy of that. So stick that in the back so that if I read this thing, it's like, what did I ask him to do? Turn back, oh yeah, there's my memo, so that's what I asked him to do. So that'll help your boss or supervisor or whoever to be able to understand and interpret those results. Okay. Also want the raw data sheet in there. Okay. And raw data sheet is the original data collection of what you did. So if you write the data down on a piece of paper, columns or whatever, and take the data by hand, a copy of that data is what I mean by the raw data sheet. So that's what I want. So it's not a spreadsheet. If I've taken that data that I wrote down and copied it into a spreadsheet, that's not the original. Now if I use a laptop to collect data. You guys are welcome to do that if you want to use a laptop and be able to type the data straight in. I'm okay with that. And then that becomes your original data sheet because that's the original place where you recorded that data. But if it's a handwritten sheet, I want to see that handwritten sheet because that's what we need to be able to go back to if we find goofy things, if we find errors. I want to be able to go back to where that data were originally put into that and say, okay, was there a mistake in transcription? Was there, was there something that's kind of obvious? So that's what I want to be able to go back to. Does that make sense? So that's what I mean by original data that we got there, okay? Now, if it's a lot of data, if you got a big long spreadsheet, I don't want 6 pages of spreadsheet data in there, so I don't need that. But if we've got room to put the data in there, then we include that data. Okay.
Are we submitting one report per group or one individual?
So we will break this up, and it will depend on how we test, and this may vary a little bit from week to week depending on the activity. So Wednesday, so we got groups of 5 people that are going to be testing. We have 2 dynamometers down there, and we have a whole slew of tractors, so we'll be able to switch tractors through and test a couple of them. So what we'll do is allow you to work write the report up with whoever you are working with on that group. So I don't want any more than 3 people doing reports because one person writes it and the other 2 don't pay attention to what really happened. So that's what we want. So I will allow you to do groups to write up group reports, but you don't have to do it as a group. Okay, so it's not required. So if you've got somebody that's slacking and not holding their weight, say, okay, here's the data, you write your own. We're not going to give you my grade any more than that. So that was kind of fun last semester when I had a student that was slacking off like that. And he came to me and said, they won't put my name on their report. I said, did you write it? And, oh, take the data and write your own. You got to do the work. So that was kind of fun. I enjoyed that a little bit, to hold you honest there. But the other side of it is the fewer lab reports I have to grade, the better mood I'm in. So, so there's that side of it too. So I enjoy that. Does that make sense? Yep. So answer your question. So it'll depend on who you're working with down there. So whoever works on one particular dynamometer and tractor they can work together on that report if they want to. But it's not required. A group report is not required. It can be individual if you want to. Okay, good. Questions about that? Good to go. All right, again, read through that report format thing, and the first week, first lab report, it might be kind of goofy, and we may, be some adjustment. I will try to. Those reports are due a week after, so I give you a week to write them up. So if we do the report on Wednesday, do the test on Wednesday this week, the report will be due the following Wednesday. I'll try to get that back to you on Monday, graded, so that you know what you're doing for the next lab report, so we don't be propagating the same mistakes for a couple of weeks till we get them cleaned up. So I'll try to do that. Good. So we'll adjust it. So you'll find throughout the semester that my grading will get a little bit tighter. So I don't hand out rubrics like a lot of people do. I'm more traditional, old school on this, but what I want to do is try to tighten you guys up and make you better. And when you think about that logic, if I have a goal where I want you to be by the end of the semester and I use that rubric for report 1, you guys all get really crappy grades on that first report. And so I don't want to bury you like that, but what you will see me doing is the comments and stuff that I make on that first lab report, on lab reports 2 and 3, you're going to start losing points for that stuff, more points for that stuff, if we don't adjust and get better. So that helps us to all get better. We're all going to have, be able to maintain some decent grades through the semester and so forth, but we're all also going to be improving and getting better. Okay, make sense on how I approach that? So that's what I'll do. Good deal? All that? Procedures? Hey, all right, we're ready to go. All right, so that was procedures, that was lab reports. Let me mention briefly that OECD reports, Organization for Economic Cooperation and Development, whatever. So the tractor test reports. The best way to find those, the easiest way to find those, is to look at the Nebraska Tractor Test Laboratory. So if you Google Nebraska Tractor Test, okay, you'll find their website. And they've got pretty good website that talks about all their history and all that kind of stuff. But part of what they have on there is a repository of test reports. And so you can go by manufacturer. I think they have a search engine on there so you can find them. If you just Google OECD tractor test reports, there are some other sites that have repositories for them as well, but I find that the Nebraska one is the easiest one to use. And so, like I said, you look by manufacturer, you go through by model number, and you'll be able to find the vehicle that we have and find that test report. So that's the easiest way to do that I find. Okay, so let me know if you have trouble finding those, and you'll have to look up the one for whatever tractor you get, and you don't know which one you'll get until you get there on Wednesday. So we'll kind of go through that and make it happen. So that'll work. Questions? That's where you find them. Pretty easy game. If you have trouble finding it, I'll help you. We'll make sure that you get what you need. All right, so when you come to lab, anytime you do a lab, anytime you're doing some kind of a test, not just for labs for this class, but in general, you know, when you're working or something like that, somebody sends you down to the shop to do something, to test something, you ought to have a pretty good idea of what you're going to get. So that means you ought to have an idea of what data that I want, what shape should it look like, you know, how should this thing be responding. You should have an idea of what you get. You may be surprised. You may get down there and be totally surprised. And sometimes we do exploratory stuff and we really don't know what's going on. But you ought to have a little bit of an idea or some suspicion of what's going to happen, a hypothesis, I guess, if you will, we call that. Okay, so let's think about this on Wednesday. So we're testing a tractor output on a dynamometer. What are we going to get? What should we have? And what should it look like? We talked about that in the videos. So I showed you that curve. What's that curve look like? What are you going to be getting? Tractor performance curve. What was going to be on the axes?
Engine speed, torque,
Engine speed and torque. Okay, which one do I put where?
torque vertical.
Put torque on the y-axis. Put speed on the x-axis and or omega, whatever you want to use. Typically, that's what I do. That's what I put up there. Okay. Now, do we say that? Here's something. Do we say that torque versus speed or speed versus torque? How do we say that when you're writing that up? Doesn't matter which way you go. Ooh. We have to write it. I always forget it. I don't know what's going on. So, always. And I've had some people argue with me on this, but you look at writing standards and so forth. It's your y-axis versus the x-axis. So this is a torque versus speed curve. All right? So that's what you're going to get. So what's it going to look like? What should it look like?
Depends on the engine, how fast it's going.
Right, and I'm not going to put numbers on there. I just want general shape at this point. So just give me a general shape. What's it going to look like?
It's kind of like that.
Going to be a curve, all right? What's it going to look like out on the right? Going to kind of go down. Yeah, so I should see something that looks something like this. So I'm going to have a curve that goes up, and then it's going to turn and give me a loop like that. So I should have something ballpark like that. Okay, what's going on? All right? This is a review from the videos. So identify some points for me. What's this point? Where that turns up there, what do we call that? Remember?
Red line.
Max, what'd you say? Max?
Power.
Max power. That is going to be probably where the maximum power is pretty close, yeah, but what's going on up there? So why does this curve have two different shapes? So I've got kind of this pretty straight looking part of the curve here, and I've got the round part of the curve up on the top. What's going on? And those two different parts there, what's happening? Come on, help me out. Wake up Monday morning. Oh man, you remember the governor? I did talk about the governor in one of those videos, didn't I? Yes? No? Did you really watch them? Did I post the wrong videos? Maybe. I did show this curve and talk about this curve, didn't I? Didn't I label this point up here? I thought I did, all right? What's going on out here? Right, and the way we typically test these engines, so let's start off on it, and this is probably how you're going to want to test this in the lab down there. Typically, you hook your dynamometer up, you turn the tractor on, whatever. We run the thing wide open or set it to whatever throttle we're going to run. But the first test we'll probably do, we'll just run it at a wide open throttle. So just open it up. So it's running at a really high speed. At that point, we have not loaded the engine yet, so we haven't started to put the brakes on that dynamometer. So it's just spinning out there happy. So I'm out at a really high speed. How much torque is there in that tractor turning, that engine turning? Is there any torque? No, there's very little torque. So that's where I start down here. I start out at a really high speed, and I've got a fairly low torque. Okay, now we're going to find when we get in the lab, is our dynamometers don't like to go to zero, so they're kind of old and creaky or whatever, so like me. So you're not going to be able to get zero torque. You're going to have some torque out here. So we'll start out here at a pretty high speed, fairly low torque somewhere up in here. Now we start to load this thing down. So we start to load that dynamometer, and we start to squeeze on it, and it starts to resist. All right, and when it does that, it's going to slow down. Well, what's happening inside the engine?
More load.
More load. There's part of an engine we talked about. I talked about that governor. Do you remember the governor of an engine? And what does a governor do?
Limits engine speed.
It limits it, and we think about that. So, and we you know, in common vernacular, people that have been around engines they say, oh yeah, I've got a governor on that engine, and the governor limits the speed, but that's not the only thing it does. It doesn't just limit the maximum speed. The governor is trying to control the speed of that engine. Okay, so it's doing something. So if it's a gasoline engine, I'm gonna, you know, or a spark ignition engine, it's gonna open or close the inlet, the intake through that carburetor and allow more of that fuel-air mixture coming in and out. If it's a diesel engine, I'm going to put more fuel or less fuel into that injector. Okay, so I'm going to be doing that. So that's what the governor does. The governor is looking at the speed of the engine and saying, okay, as the speed gets higher and higher and higher, it says, whoop, less and less and less, slow down, okay, hang on here. So interesting thing about internal combustion engines, if I don't have something on there controlling speeds, there's nothing to stop it. It will blow up. So get on YouTube and look at runaway engines, search for runaway engines, and you'll find a lot of them that the governor sticks or breaks, and it doesn't limit the engine. So if there's no resistance to that load, it just keeps going faster and faster and faster and faster and faster, and eventually something flies out of the engine, literally. I mean, it will literally explode. Rods or different parts of the engine will come flying out of it, so it'll literally explode. So I have to control that speed. So, and again, we common vernacular, we talk about, oh, okay, you know, we got a governor up here that limits the maximum speed so that it doesn't blow up, and yes, that's part of what it does. It shuts the thing off when it gets too fast. But as the engine starts to slow down, the governor sees it and says, you know, it's a mechanical mechanism, it might be electronic, there's different ways that we can do it, but it says, oh, it's slowing down, I'm going to put a little bit more fuel to it. I'm going to help it out here. So open up, let a little bit more fuel to it. So more load, more fuel, more load, more fuel. So what happens up here at this point? We have that straight line going up there, and when it turns, what's going on? The governor is open. So the governor says, that's all I got. I'm wide open. So the governor is at, and we call that the governor max. Okay, so this is what we call the governor max. So that's the maximum that the governor can give me. It's open, it's like, yep, that's all I got. Now I continue to load the thing, I continue to put more torque on the thing, more resistance, and squeeze tighter and tighter on that dynamometer. What's going to happen to that engine? It's starting to slow down a little bit more, but I get this hard turn here because the governor is no longer controlling it. So I have, most engines are fairly linear, so that governor acts pretty linearly all the way down there. So we'll see that. And depending on the engine, the steepness of this curve might change. So some of our newer modern engines with real accurate electronic controls and everything, they might do a really good job at controlling that speed. So you might see this pretty doggone vertical. You get an older engine with the governor that's kind of worn out or whatever, and you might see a little bit more slope on that curve, so it might lay down a little bit more, so it won't be quite as straight, okay? So the steepness of that curve, and this is one of the things that I didn't mention in the videos that I want you to do in the lab, is to quantify that. So what I want to try to do is find from your data, I want to find that governor max, and it might be kind of tricky because the data starts to curve and gets a little wonky up in there, so we might be doing some estimating, but that's part of the challenges of an engineer, is interpreting your data, interpreting what you have. So we try to find that governor max, drop down here. Now the governor droop, when we talk about governor droop, this is how much that engine slowed down from wide open throttle with no load all the way up to governor's max. So that's what the droop is. And again, you may have to do some extrapolation, a little bit of extrapolation, because our dynamometers won't give you this zero torque curved point down here. So it's going to start up here at 0, so you might need to do some straight lines stretching out there or something like that. But that value, this distance from there to there, is your droop, governor droop, okay? And again, some engines are going to be really tight. They're going to have a really small governor droop with good tight electronic controls on them. They might do that. If older engines or cheaper engines that don't have as expensive of components in them, they may have a little bit longer governor droop. So that's what you got. Make sense? So that's what you're going for there. All right. So, and then we go up to maximum torque up here, and I think I talked about the torque rise. So from here to here, actually the torque rise is often defined from the maximum power point. Where's the maximum power going to be? So Courtney, right? You're Courtney, right? Okay, working on names, help me out here. So I'll ask stupid questions. You'll be like, yes, I'm Courtney. I told you that 6 times, but I need help, all right? So you already told me the maximum power is right there, right? So why is maximum power? Why is that maximum power?
Governor's all the way open.
Governor's all the way open, right? So what do I have to have to get power?
Power is a function of torque.
Yeah, I got to have torque, and I have to have times, power is torque times speed. Yeah, I got to have torque and speed to give me power. So I got to have a lot of torque and a lot of speed. So down here I got even more torque, but I don't have near as much speed. Up here I got a lot of speed, but I don't have very much torque. So it's somewhere in the middle in there, okay? Now this is one of the things that you're going to run into as you interpret, as you look at those tractor test reports. So you're going to look at the maximum power. And it's going to be easy for you to find it. So you've got torque, you've got speed, calculate power, and you get that little curve. I think I showed you that curve in there, so you should have a curve. And let me change my color here just to be kind of funny. So I'll go green. So the power curve should start at 0 power. I should get some kind of a peak up in here, and it's going to go roll off like that. So the power will look some kind of a shape, something similar to that, right? So maximum power somewhere around this corner in here, something like that. Now, what's interesting is that your manufacturers will talk about maximum power. By the way, max is an abbreviation, so when you're writing lab reports, so if you use the word max, it has to be an abbreviation with a period after it, so it's abbreviation for maximum. Remember that, So some of those things that you lose points for later in the semester. So we got maximum, and you have rated torque, or rated power. And sometimes they don't match. Now, what in the heck is going on? Manufacturers, what are they doing here? I got maximum. So maximum is pretty easy to find. But that may not be my rated torque. All right, and I'm going to have one more. I'm going to have maximum, I'm going to have rated power, and I'm going to have power at my PTO speed. Oh man. So, and we'll see the shaft on the back of the tractor that we're getting the power out of is a power takeoff shaft. That's what PTO stands for. And it's a standard size shaft, standard size splines, all that kind of stuff. We'll see it down there. I'll show you, we'll look at it and all that. But there's an expectation for that shaft that's running an implement that's connected to that tractor back there that it'd be rotating at a certain speed. And so we have a couple different standards that we operate with. And those two standards, the two primary standards that we see are 540 RPM and 1,000 RPM. And so, and again, I'll show you the difference between those two, but one of those says, hey, that shaft should be rotating at either 540 or 1,000 RPM. So if I'm designing an implement on the back, I'm expecting that rotational speed. So that rotational speed is going to be tied to the engine speed typically. So if my engine goes faster, that shaft goes faster. And engine goes slower, that shaft goes slower. And so you're going to find that you're going to start, you're going to hook to the power takeoff shaft, but you're going to start above it. So if it's 1,000 RPM, you may start at 1,100, 1,200 up here, and then you're going to take it all the way down to maybe 500, 400. I don't know how far you can get it before it stalls, but something like that. So you're going to see a big variation. So somewhere in there, that engine is going to be operating at my expected speed, which is probably going to be close to this maximum power, but not necessarily right at it. You might be close to the rated power, so not necessarily right at that. It's like, what the heck is going on? So those are all close. So what's happening there? I mean, obviously the power at this speed, at the power takeoff speed, I mean, we know that, we can match that, we can find that. Is that at the maximum power of the tractor? Typically it's pretty close. So it's in the manufacturer's best interest to say, hey, if this is a 100 horsepower tractor, I should be able to see 100 horsepower when I'm operating at that rated speed out there. Okay? But why might my rated power be a little different? Let's think about that a little bit. What would determine that rated power? If I'm going to rate something, now think like an engineer. I'm going to give you a rated power for the engine. What's going to determine that?
Flywheel power.
The flywheel power. So it's the power that I'm measuring.
Without drivetrain loss.
Right? Without drivetrain loss. Well, I'm not thinking about efficiencies at this point. I'm just thinking about that operating point. How do I know where to choose that rated power? Should I choose it here? Should I choose it up here? Should I choose it down here? Where should I choose the rated power? If I'm going to rate an engine, what implications go with that? Again, thinking like an engineer now. What implications go with that rated power? If it's rated to operate like that, and it's not necessarily at the maximum, why would it not be at the maximum?
Well, when you got to start pulling something, you got to, like, so for example, if the truck's towing a boat, it's going to have to work its way up to getting towing the boat. It can't just, take off from like a
right. So I have to be able to get up to it. So there's got to be some, I'm either coming from here or coming from this side of the curve to get into it. So I got to come from one way or the other. Yep. And part of that is going to be the torque. So there's where like this torque rise and all that goes in there, to how quickly an engine can recover and get to that point, right? So could I get more power? The more power, let's just say that I have an engine and I'm trying to choose a rated speed for it. I can get a lot of power out of that engine, but I can also rate that engine power somewhere down here at a lower speed and a lower power output. What advantage might that give me? What about longevity of the engine? Oh, might the engine last a little bit longer if it's not working hard? Might it vibrate less? Might there be some other things like that going on in there? Oh, so there's some other factors like that when we talk from an engineering standpoint, when we're going to give a rated condition or a rated performance for a piece of equipment. It's not just engines, but for anything, how am I going to rate the performance of that thing? What conditions? I could probably get more performance out of it or a little bit less performance, but what am I sacrificing in terms of longevity, in terms of fuel efficiency? Maybe it's not really very fuel efficient at that other point, and I want to be able to say, hey, at this rated speed, this is my fuel efficiency. Now you can work it harder than that, but it's going to suck a lot of fuel. Probably more than my competitors, so that's why I don't want to put that number out there, right? Okay, so you start to see some of those games that we play on that. So you're going to run into that. You're going to find that for most of these tractors. Some of the older ones don't have all those, but on the newer tractors that we test down there, you're going to have a rated engine speed. You're going to have a speed at its power takeoff speed, at the rated power takeoff speed. You're going to have a power, that's the power of all those three. You're going to have a maximum power. And those are all three going to be different. So those are things that you need to look at. So just looking at maximum power is not necessarily that simple. So it's going to take a little bit more thought for you guys to look at your data, to look at what you collected, go to that report and say, okay, is this stuff all matching up? You know, what's my peak power? Where is the rate? Where is that 1,000 RPM at? Where's that power there? You know, I wonder why they chose the rated power where they did. So some of those kind of questions that I want you to struggle with a little bit and to look at and to wrestle through as you're interpreting and comparing your data to what's going on with those tractor tests, okay? So does that make sense? So a little bit more, digging a little deeper. It's not quite as simple as just, yeah, here's the maximum plotted out, boom, there we go, going home. So I want you to really think and look at that test report and try to understand what's going on in that test report. All right, makes sense? Questions about that? You need to struggle through that anymore? All right. So now the next question, and I'm going to ask you before you have a chance to ask me, because if I don't say this, you're going to ask me when you come down to the lab on Wednesday and say, how many data points do I need?
That needs a take.
And that's going to be my answer, as many as it takes, all right? So think about that, all right? Let's think through, how many data points should I collect? What do you think you need there? Or where do I need the data? Or how do I get that data? Okay, so what are some philosophies and some thoughts that should go into which, you know, where do I collect data points along that curve? So again, we're going back to this main blue outside curve here that we're trying to pick up. So where do I need more data points?
Around the governor max.
Around that governor max, because that's where I know a lot of stuff is happening. That's where I know my peak power is going to be somewhere on there, typically maybe a little to the left of that. I know that my rated engine speed is probably, that rated PTO speed is probably going to be right around in there somewhere. The rated engine performance may be in there. So yeah, I'm going to want a lot of data points in through here. So when we start getting up to that point, I want a lot of data points along there. I want to really be able to fill that curve in, okay? This is a straight line down here. How many data points do I need along that line? Few. How many points does it take to define a straight line? 2. How many does it take to prove if it's a straight line or not?
Yeah.
3. You could disprove it with 3, and maybe you could prove it, I don't know. So yeah, do I need a whole truckload of data down through here? I don't need a lot, but I should have a few points down in there, right, to collect that, so that's kind of key. All right. How many data points do I need down along here? Maybe a few. The key thing that I asked you to do, that I asked you to focus on, was around here. If you look at the memo, I didn't ask you for the maximum torque. Okay, it's fun to see it, it's neat to see it. And it's going to be fun to take the engine down and, yeah, make it groan, make it whine. It's all right. It's not going to hurt it. If you stall it, we'll start it back up. It'll be okay. So, you know, we can go down to the end. Now, one of the things I'll tell you is, look how the curve comes back down. Think about that for a second. So I'm loading those brakes in that dynamometer. So I'm putting more force, you know, more torque, if you will, resisting that thing. I get up to the maximum, and I have the most torque on there. Now I put a little bit more resistance, what's going to happen to the engine?
Slow down really quick.
Really quick. In fact, if I go down here, it's going to shut off. It's going to stall. So it can no longer recover. And so, you know, with that much resistance, with that much torque on it, the thing is just going to shut off. So, and this is kind of tricky, and some of you may get lucky and may be able to get a few data points on this part of the curve back here, but literally what you have to do is, as you load it, that engine is going to slow down and it's going to continue to slow down and die. So what you actually do is actually unload it a little bit. So you have to lower the torque. And then it becomes kind of a balancing act to hold a lower torque out here, take some of the resistance off. And it's going back to what you're saying about taking the truck and getting the boat started. So I'm beyond my recovery point for that engine. So the engine's not able to recover and come back up because the speed is too low. But then I've got that lower torque back in there. So it's really tricky, and you don't have to get it back in here, but it's kind of fun to play with it, you know, if you got some time down there to play with it and see if you can get a few points back across that curve back there. But this is going to get really flat out in here. So the other thing you have to think about is your philosophy for how you're going to collect the data. You know, what are you going to use for intervals and stuff like that. So I'd encourage you to get down there, turn it on and play with it, you know. Load it down to get an idea of like, okay, where does this thing hit, you know, look like it's really hitting that peak torque? What is that maximum torque going to be up in here? Just kind of get some idea of where you are and then what the speed's going to look like from that point. But when you start down here to load torque and you start loading it down, you're not going to hear much on the engine. So think about this. My torque is going to jump up pretty quick, but the engine speed is not going to vary very much. So I'm not going to hear much happening there. So I'm going to be able to see it in the data. I'm going to be able to see that torque jumping up. And you'll hear it, but you won't hear it too much. Now, when I get up in here and I start changing it, if I watch that torque is not changing a whole lot. So a little bit of change in torque is going to make a lot of change in the speed. So I changed my data collection philosophy. So coming up here, I'm going to be watching for torque and probably looking for torque every, I don't know, whatever your scale is, maybe every 50 foot-pounds or something like that, and just, you know, collecting data. Now, when I hit the top, now it's going to be a matter of listening. So I'm going to tweak a little bit on it. I may only add 2 or 3 foot-pounds of torque, but I can really hear that engine slowing down. So I'm making big speed changes in the engine. So my philosophy changes. So all those nice labs that you did with, you know, in your freshman, sophomore classes and everything, they say, you know, collect data points every 10 value or something like that. It don't work here. So now you got to be smart. You got to think about, okay, am I going to do it in even increments of torque, or am I thinking about speed, or where am I on the curve? Understand where you are on this curve. I've hit the peak power. Now I'm going into the engine control. I'm out of the governor control. So that makes a difference of what's going on. Does it make sense? So that's what I want you to think about. These are the things where we're growing up and becoming engineers and not being students that follow directions that you get on a step-by-step lab sheet. This is where we have to start thinking about what data do I need to collect so that I can report back to my supervisor. Look, you don't want to collect more data than you want to, right? You don't want to spend more time down there. You're all lazy, right? Yes, okay, admit it. Guess what? If I'm paying you, I don't want to pay you to do stuff that's not meaningful. Okay? If you're getting paid by the hour or whatever, I don't want you wasting time down there collecting a lot of data that's not meaningful to me. So I don't want you to collect data that you don't want either, as a supervisor. Okay? So those are the kind of things that being efficient with your time, making sure you've got enough data to be able to answer the questions, that's what we're going to try to work through and try to learn how to do. Okay? Is that a little bit scary? Maybe not. Maybe kind of nice that somebody's actually treating us as adults and as engineers and not as follow the instructions, fill in the blanks kind of a thing. So it's going to be refreshing, but it's going to be a little bit more of a challenge for you to think about as well. Questions or comments about all that? We're good? You ready to do this? Long pants. These are fun. It's a fun lab. So the really fun ones, if we are still in a couple. Actually, we may just do this next week. I'll see what I'm doing to schedule. But we'll put some alternate fuels in these engines. So one of the fun things we do is get out and get to Kroger and just get cooking oil. So like, you know, regular canola oil or whatever, and we pour in and watch them go. So we can run them on canola, on cooking oil. So you get a little different power output. The exhaust smells like French fries. It's kind of fun. So we'll do some things like that. So see what the different fuels do, how the performance changes with a different fuel in that same engine. So we'll do some of that kind of stuff. So this will set us up, give us good procedure, learn how to use equipment. Next week we do some other stuff for you. You good? All right, if you have no more questions, nothing else we need to discuss, then I'm done. And we'll see you sometime Wednesday morning, 183 lab groups. So, awesome. 186 is the number. If I didn't say that on it, maybe I did. 186 down there is where we'll make